Hi everyone. Nice to meet you all. Hi. No pressure. I've heard quite a few people have been looking forward to this one, so yeah, feel free to disagree with me at the end. So I'm John. I am the founder of BrainCube. We are an AI engineering agentic consultancy. So what do we do? What do we do for our clients? Production software. So at the MVP stage, I'm not suggesting we're building things that are serving thousands of users yet, but we have real traffic and therefore, real data points. Agentic enablement. So for our clients that have more regulatory requirements, we will go in and architect solutions for them. And we also do code-based audits. So there's a lot of appetite now to build personalized software. And often the people that are building this personalized software are not traditionally engineers, but they can Claude Code or Codex. So code-based audits have been very popular lately, as you can imagine, and that's usually for clients that want to take what they've got as a proof of concept and move it into an MVP that's serving real users. So I want to ask the audience a question. How many of you have used agentic software development tools? Everyone in the audience? Not everyone, but I'll say about 90%. Okay, and for those of you that haven't, is anyone brave enough to just say why? Yeah. Because you can't code by yourself. Okay. All right.
Or you don't want to be lazy sometimes.
You don't want to be lazy.
Either you want to be lazy sometimes.
Oh, you want to be lazy.
So the one that moved forward, okay?
Oh, yes.
It's old days when it took 4 days or 5 days. Mm-hmm. It just takes 5 minutes these days.
Yeah. All right. So look, I'm gonna deliver 5 lessons that I've learned in achieving all of this with BrainCube. There's no significance to the 5 that I selected. It's just lessons I thought were interesting, and I've come here today to share those with you. So, without further ado, let me move on. What was the goal of BrainCube? I'll say it's fairly ambitious. I wanted to build a software factory, right? What does a software factory mean? It means specifications in, production software out, right? It sounds crazy, because it is. Building a software factory is like a North Star. It's almost like an impossible goal, really. But I like to position it there because it guides how we prioritize things, how we work on the agents that we have within BrainCube, and how we work on building the systems that we have to build production software. So in the software factory, this is kind of where lesson 1 comes in. There's this. How many of you have heard anything about spec-driven development? Okay, cool. How many of you have tried spec-driven development? Quite a few people in the audience. How many of you tried spec-driven development, but you didn't know you were doing spec-driven development? Okay, yeah, sounds like it. So you won't specify the whole system up front. You can try, but you're just not going to do it. And I've got an example of it in my own work. So my workflow would look something like this. I would usually interview the client and get an understanding of their specifications. All right, and we put together some questions to do that. And over several rounds, you build up an understanding of what they require from a software, okay? Then you, as the technical person, can go back and forth with your favorite Claude or ChatGPT, whichever one you use. You can use, there's skills available to do this. I'll get onto skills a bit later, but you can do that and try to get to a point where you think you've covered every gap in the specification. And what I did was have that done and then send that off to Crawl Code, which is my custom harness or codex at the time, and have it deliver the first iteration. And inevitably, whenever I would log on to the application to try and test it as a user, something would be missing. There was an edge case, there was something that just wasn't picked up in the specification. So in this example, we're building an embedded agent. Who knows what embedded agents are? Okay, so let me help. Voxel 51, the agent that Harpreet just showed to you, that's an embedded agent. It's an agent that lives on the platform where you're working. So we build a few of these for our clients, and one of the requirements that we have is that you can audit the agent, you can see what it's doing. So you saw that with the agent that Harpreet demonstrated. I'd spent hours, what am I talking about, days, with Claude and with Codex going back and forth, writing the specification, but inevitably when the agent delivered the application, the progress, the ability to track the progress of the agent on the user interface just wasn't there. So that taught me that you shouldn't shoot for perfect specifications. What you should be doing is accepting that you're not going to specify 100%. You will probably get 80%, and it's the iteration on top of that that gets you close to that 100%. And that is the journey of building software. Okay, so I'm going to move on to the next lesson. Enforcing a test-driven discipline. So this comes from another real story with a client that had vibe coded a piece of software and wanted that software to serve users, okay? So naturally they come and they ask if it's possible to move this software into a production state. So the first thing I look at is, well, there's no tests in this software. So naturally, what do you think I tried to do? Anyone want to shout out?
Number of users.
Retrospectively fitting tests.
Data harness.
That's right. Retrospectively fit the tests, okay? Right. Has anyone tried that? Okay. So I'll tell you that in my experience, it doesn't tend to work that well. And the reason it doesn't tend to work that well is the agent writes the tests to pass. And I'll give you an example here. I'm going to get the red pointer because I think it's easier to show. And I'll apologize ahead of time because it might be a little confusing, this diagram. But this is a very simple test. It tests an input field into a form, right? So we're trying to validate the data entry into these forms. The first name has to have a certain character length, and you can see we've defined them here. So we write a test, but can anyone notice what's actually gone wrong here? And this is not an exam, it's just anyone can call out quickly. So notice that the test input is the same as the test rule. So what we're trying to do here is we're trying to assess whether a change that the agent has made to the code is going to break the functionality that we intend. So for example, if the agent makes a change to the code and instead of accepting a first name of only 100 characters, now it's like 5,000 characters, we want this test to break. We want it to scream so we know, okay, the agent's done something silly. But the way this test is fixed, the code moves with the test. And that's how agents retrospectively fit on a code base that you've already created. And I found many of these examples. I think this was actually done with Opus 4.8, the retrospective fitting, but I found many such examples. So here's an example of where it breaks. Now the field value, the input is going to be 5,000. Oh, sorry, apologies. I think I might have skipped So this is an example of how it should be. You should have expected limits, so the test constraints set outside of the code. So when the agent is making changes to the code, it can't change the test constraints. So in this case, when you get the field limits company value set to 5,000, which we don't want, the test is going to scream. And if this is merged correctly into your CI, it breaks and the agent can't merge this code to the code base. And that's what you want. So the question is, if retrospective testing leads to the first type of error that I showed, what can you do about it? So you enforce a test-driven discipline from the outset. As the agent is generating the code, what you want to do is ask the agent to write the test up front. So now the test is actually testing the real behavior that you're trying to specify. So there's a technique called red-green refactor. I didn't make this up. I believe it was Ken Beck that created this technique. But essentially what the agent does is it starts by writing a failing test, then it writes the code to pass that test. So the code is written to satisfy a behavior that we've specified up front. And then you clean up the code. So it's iterative, it's a loop. So I actually enforce my agents to work in this manner. And I see that this reduces the number of the first type of error that I talked about, that retrofitting tests that don't actually test any of the behavior of the system. So I'm going to move on to the next lesson. And this is one that's interesting because Harpreet covered a little bit about this before. And this is about repeatable workflows. So, how many of you know what skills are? I know Harpreet asked this before, but how many of you know what skills are? Okay. What about agents.md? Have any of you heard of that? Claude.md? Okay. Yeah, so these are all forms of context management because what they're doing is revealing the information to your agent that it needs to conduct a task. So if you've created a custom harness, which I'm sure, how many of you have created a custom harness in the audience? Okay. Okay, so let me simplify. How many of you have added some skills to your Claude code? So you're customizing your harness. So the reason you do that is because agents.md and skills reveal context to the agents in different ways, okay? So the lesson here is repeatable workflows belonging to skills, persistent behaviors you want to put in agents.md. So when I was trying to get my agent to enforce a test-driven development discipline, what I would do is I would have the fact that when to use the test-driven development discipline in the agents.md, because that needed to go in every message, because it's iterating, it's doing loops and cycles of software generation. How to do it, materialize in the skills. It's important because skills are progressively disclosed. So that means they don't pollute the context with lots of information. Essentially, having a skill is like having a library of books and you just see the title of each book, which tells you a bit about what's in the book, rather than having to ingest the whole book to know about it. So skills are a way of effectively communicating context to the agent as and when it needs it, rather than everything up front. Whereas the agents.md or the Claude.md has all of that context always with the agent. So that's more for persistent behaviors, whereas this is for procedural behaviors. If you want to know when to use skills, think about your standard operating procedures. Those are the things you want to encode in skills. and persistent behaviors you want to encode in agents. I'll give you a link to some useful resources about skills at the end if any of you want to learn more about that. So we'll move on to the next lesson. Verification is mandatory. How many of you have had Claude lie to you? Right. Does anyone want to say what Claude lied to them about?
Yeah, I've done it. It's working.
Oh, right. Yeah. Okay.
I've written it. I've saved it on your desktop.
Yeah, it saved it. Yeah.
Saved it in its own virtual machine.
Or like, has anyone seen the failure mode where it accesses a phantom tool? Maybe I think the latest ones don't really do that anymore. But like, I remember like the Opus 3.7. It's hard to keep track of all of the different models, but in those days, I remember it used to tell you it accessed a tool that didn't exist in your workbench. So this is where the verification piece comes in. I think verification is mandatory because agents are built on top of language models, multimodal models, and these models are probabilistic by nature. So you need verification. So again, how I came to this was obviously building out production software. I'm looking at I'm not just building one part of the software. This is often greenfield projects or projects moving proof of concepts to MVPs. So I'm looking at the user journey just as much as the back end stuff, right? And what I would find is, on completing my specification, I would ask the agent to build a feature, and then I would have to manually get onto the application itself and check that the feature actually came in as it was, right? So I was effectively turning myself into a verifier. That's all I was doing. How many of you had that experience? Yeah, how many of you have had that experience of being the verifier, essentially reviewing over and over again what Claude generates or what Codex generates? How many of you enjoy that experience?
In the end, you have to write a skill to say, keep doing it. Till you have 100% accuracy.
It's a frustrating experience, but I think in frustration comes some of the most valuable lessons, because what that tells me as an agency owner is you need to automate that, okay? So I found the smallest way that I could automate manual UAT that I was doing, manual testing of web applications. And that was actually to get Codex to use Playwright to record a video of it working through user workflows. Has anyone tried this?
I when you gave me the prompt, they didn't give you the same response again.
Sorry, I'll take questions at the end if that's okay. Yeah. So I see a few people in the audience have tried it. So I found this to be super effective because now, instead of believing that Codex or Claude Code did the thing, I actually have a video artifact as proof to show that it did the thing. So then it's like, well, am I going to spend all my time watching videos? No, I didn't really fancy that. That's quite a low value activity. So instead, you set up an external verifier. That external verifier is simply Gemini 3.5 Flash that has a video understanding model. So what's difficult about verification is setting out the criteria for the verification. Gemini 3.5 is just another language model, but it does sit outside of the system that generated the video artifact in the first place. So that brings a level of independence. It has a different context, but you still have to tell it what good looks like so it can tell you that the thing that was delivered met your criteria. So I managed to solve this little loop for software that I'm developing. And essentially what that has done for me is given me the hours back to allocate my time to higher leverage activities, because as an agency, we're under pressure to deliver software quickly. That's why people come to a small agency, because they believe you can move faster and managing multiple clients at a time. So the key lesson here is where you're asking agents to do things, you do need to verify that they've done it. And ideally, that verification needs to exist outside of the agentic system that produced the work in the first place. So it needs to be independent. Whether that's you or whether that's an automation is fine, but it needs to be outside of the system that produced the work in the first place. Okay, so I think this is my final lesson that I learned. So the lesson's written up there. Use your tokens efficiently or pay the price. This is my actual Codex usage over the last year. I couldn't tell you what I was doing in the gaps. I thought I was working. Maybe I was having a breakdown. But it looks quite impressive. I didn't track this myself until recently, but it's 36 billion tokens. This is done on a $200 a month plan. I asked Claude, so if these numbers don't make sense to you, I'm blaming Claude right now, but I asked Claude to calculate what that would have been if I had to pay by the API. As you can see, this is expensive, right? Yeah, it's not cheap. So the lesson here is, if you're using agentic harnesses, we do not know how long we're going to get these subsidized tokens. We don't know how long we're going to have access to frontier models. So you need to build harnesses to be token efficient. And token efficient for me is, what is the cost per unit of completed work? That's, again, another North Star, isn't it? Because what's a unit of completed work? How long is a piece of string? It's hard to define that, right? That's why everyone defines developer productivity with PRs, because it's the easiest thing to measure. But this is a goal that we're always working towards. How do we bring that cost down? And there's several ways that you can do it. I think skills is one way, because skills, again, reduces that exploration surface for the agent. It's not consuming so many tokens, just exploring stuff. Another way is looking at multi-agent architectures and delegating narrow tasks to smaller, cheaper models. And we've seen examples of smaller, cheaper models in talks today. So delegating effectively to smaller, cheaper models. Another way is ensuring that your setup is correct. If you're deploying Claude across enterprise, things like, I don't know, maybe have prompt caching enabled can reduce token spend. There's a bunch of other lessons that I can cover, but I think this is all going to be circulated after the talk. So feel free to grab your copy. As I said, we're BrainCube, agentic enablement, strategy, custom agents. If you're interested in any of that, you can get in contact with us. About a lot of the lessons in real time that I've learned from agentic engineering. We have 17,000 subscribers now, so it's just at BrainCube on YouTube. So if you do want to listen to that, go ahead and subscribe. And that is it. I hope that you found some of that interesting.